Hi, this is Rajshekar, Assistant Professor in Triple E Department. Through this video, I am going to demonstrate a simple concept of three-phase currents. Let us consider a three-phase load, and currents are flowing into the three-phase load from the point A, B, and C. And all the three currents which are flowing from point A and point B and point C are coming and merging at one point called neutral point. And let us see what happens at this point N. So at this point, since all the currents are meeting at that point, the total current at the neutral point is equal to IA plus IB plus IC. Now, since IA and IB and IC are 120 degrees phase displaced, so IB is making an angle 120 degrees with IA and IC is making an angle minus 120 degrees with IA. So substituting those values, so IN is equal to IA plus IB plus IB at an angle 120 plus IC at an angle minus 120. So converting this polar to rectangular, so IA plus IB into cos 120 plus J sin 120 and I plus IC into cos minus 120 plus J sin minus 120. So substituting the values of the cos and sin values, you are going to get 1 plus 1 into zero point 0.5 minus 0.5 plus 1 into minus 0.5. Here I have taken IA is equal to IB is equal to IC is equal to 1. The magnitude of the each current, the maximum magnitude is 1. So from this it can be observed that when IA is at maximum current, maximum value, IB and IC are having a negative values and it's almost 50% of their maximum values, which can also be observed from the phasor diagram. So here from this waveform, it is very clear that when phase A or any one of the phase is maximum, the remaining two phases are opposite direction, are negative and having a magnitude equally half of their maximum value. When these currents from phase A is coming and meeting at a neutral point, it has a option of going into two remaining two phases. That means IA is dividing into two equal parts. Suppose the three phase load is balanced, then IA is divided equally. And this IA, which is divided equally, is counteracted by phase C, which is equal and opposite to IA by 2, and it is also contracted by phase B, which is equal to IA, which is half of its magnitude value. So through this video, we can say that when any phase uh, current is coming from phase A or phase B or phase C, okay, the remaining phase currents will be counteracted and the total current at the neutral becomes 0. Similarly, for phase C also, we can conclude with the same remarks that when phase C the current is coming, the current is divided into phase A and phase B because it has no provision to enter into the neutral, because we have proved that the neutral current is 0. Now, the phase A and phase B currents, uh, at the instant when phase C is maximum value, phase A and phase B will be negative, opposite, and equal to half of their magnitude values. So phase A is minus 1 by 2, phase C is minus 1 by 2, phase B is 1 by 2, and phase C is 1. So the total current at the neutral point is 0. So this short video will help you to understand the concept of the how three-phase currents are flowing in a three-phase balanced load. Thank you very much for watching this video, and please do subscribe to my channel for latest videos. Thank you very much.